Okay, so in the previous videos, we have gone over how to basically kind of create the equations. We kind of, sorry, in the last video, we kind of made sense of, what in the world does y equals mx plus b mean. We really kind of explored a lot of these key concepts in terms of the slope and y-intercept. And now we're going to go vice versa. What if I give you a graph and I want you to create an equation for it, all right? And there's two ways that we can go about this. And I highly recommend that we learn how to do both methods, all right? So we'll start off with the easy method, all right? And the easy method is simple. Well, we know we need to write an equation that's in the form y equals mx plus b, right? In the last video, we talked about the plus b is our y-intercept, the m is our slope. So if I look over here, well, the y-intercept, right, the y-intercept right here is 5. So I already know my equation is going to be something like mx plus 5. Okay, and now if I pick the next logical point, well, it should be this one here, right? Because it's perfectly intersects it at 9, and we make our slope triangle. Well, it's 1, 2, 3, 4. Well, 4 over 1. And I can do the same thing over here. Well, 1, 1, 2, 3, 4, which is 4 over 1. So you know our rate of change is just rise over run, which is equal to 4 over 1, which is 4. So my equation for this graph is just 4x plus 5. See how simple it was to do that? Now, let's go ahead and do maybe the other method, which is a little bit longer, but you'll understand in a little bit why it's preferred to do this method. Well, first things first, and this is always going to be true for everything, is we know the y-intercept is 5. So we know we're going to have y equals mx plus 5. Okay. Now what we need to do is pick a point, right? And we want to find m. We want to find m. We want to find our rate of change. Well, we could do that by making slopes. Again, let's pretend we didn't have that tool, all right? And let's just pick a point. I guess we'll just pick this point here, which is 1, 9. So let me just write it over here. 1, 9. The reason why I'm picking a point is because I want to find m, but we need to know an x value and a y value, so we can plug those in. And we do. We have 1 and 9. So we're going to take the 1, plug it in for, oops, not the m, because we're finding out. Take the x and plug it in for the x, which is 1. And take the 9, which is the y value, and plug it in for the y. All right? So we're going to get 9 is equal to m times 1 plus 5. Okay? I'm going to rewrite this. 9 is equal to, well, anything times 1 is itself, so it's just m plus 5. Now we just subtract 5 to both sides, and we're going to get 4 is equal to m. That tells us my rate of change is 4. Now we can write our equation for x plus 5. Perfect. All right. Well, that's great. Now let's go ahead and look at this scenario here. And again, in this problem here, we want to write an equation that's in the form of mx plus 4. Sorry, mx plus 4, mx plus b. Okay. And let's go ahead and do the longer method first. So we identified our y-intercept, which is 3. So y equals mx plus 3. Okay. Again, I need to pick a point and plug it in so we can solve for m. So I don't know, I'm looking through this point right here. Looks pretty good to me at 4, 0. All right, 4, 0, because the x value is 4, but my y value is 0 on that line. So I'll write down over here, 4, 0. Okay, the 4 goes into the x, and the 0 goes into the y. Plus 3. Okay. Now that we have that there, let's go ahead and let's begin solving this equation here and making sense of it. Oh, you know what? I just realized I did make a minor mistake. Okay, it's going to be y equals mx minus 3. All right? Minus 3. You'll notice my y-intercept is down below. These are negative y values. Okay. All right. Well, now I just need to pick a point. I think this point right here looks pretty good to me. 4, 0, 4, 0. This is my x and my y value. See, my y value is 0. Awesome. Now let's just plug that point in. I'll just write it down over here. 4 comma 0. The 4 goes in for the x, and the 0 goes in for the y, all right? So we plug that in. 0 is equal to 4x, oops, sorry. We're trying to find m, and we plug in the 4 for x minus 3, okay? I'll go ahead and just rewrite this in a different color. 0 is equal to, well, 4 times, m times 4 is just going to be, I'll just write it as 4m minus 3, right? It doesn't matter. Just so you know over here, let's see, 2 times 3 is 6. 3 times 2 is 6, all right? So even though it was m times 4, I just rewrote it as 4 times n. You could just do that. 2 times 3 is 6, 3 times 2 is 6, doesn't matter the order. Okay, now we're going to add 3 to both sides. And I'm going to get 3 is equal to 4m. Now I divide by 4. Okay, so you'll notice my slope is 3 over 4. So my full equation, my actual equation is going to be y is equal to 3 over 4 x, 3 over 4 x minus 3. Well, what does that mean, right? Well, this is actually telling us my rise over run, our slope is our rise over run. My rise is 3 and my run is 4. Okay, if you look over here, does that make sense? Well, let's go down over here, and my run 1, 2, 3, 4. My run is 4. 1, 2, 3. You see, 3 and 4. Okay, now that's why I wanted us to do it the long method first, right? Because as we start to get into fractional slopes, it can be hard to visualize. Let's go ahead and graph this one. 1, 2, 3, 4. 1, 2, 3. Perfect. And you see it perfectly matches our graph. All right, cool. Let's go ahead now and look at some negative slopes. So we got a chance to write an equation, right? You can do the shortcut method or the long method, but I recommend doing both. Let's go over to this one here. Okay, again, we want to write an equation that's in the form of mx plus b. Let's just start off. Y is equal to mx. Let's look at my y-intercept. Well, my y-intercept is 1, so plus 1. All right. Now I want to find m. I want to pick a point. I don't know. You can pick any point that you really honestly want. I guess I can pick this point here. Looks pretty good. Or this point here. I guess I'll just stick with the negative 2 comma 6. It's this point right there. Negative 2 comma 6. This is my x value. This is my y value. Plug in the negative 2 in for the x and the 6 in for the y. 6 is equal to m times negative 2 plus 1. Again, I just want to rewrite this as negative 2m plus 1. All right, now I just subtract 1 of both sides. We're going to get 5 is equal to negative 2m. Now we divide by negative 2. And we're going to get m is equal to, well, 5 divided by negative 2. This is just the same as negative 5 over 2. Or you can leave it. If you want to, you can honestly leave it as 5 over negative 2. It honestly doesn't matter, right? 5 divided by negative 2 is still negative. Negative 5 divided by 2 is still negative. So it's up to you. It doesn't matter. So our equation is y equals negative 5 over 2 x plus 1. Okay, well, let's see if that makes sense, right? Well, we're going to go down, and this is why where you can kind of see it makes sense. We go down 1, 2, 3, 4, 5, and then over 2, 1, 2. You can see my triangle is right there. 1, 2, 3, 4. Oops. 1, 2, 3, 4, 5, and then over 2. 5 over 2. So if you wanted to, you could have still done the slope triangle and got, oh, okay, 5 over 2. But you had to be careful, right? Because it's a negative 5 over 2. Because look, the line is in this direction. Remember, positive slopes, the line goes something to this extent. Negative, the lines are in this other direction because we flipped the y values, all right? So that's something to keep in mind. That's why I prefer this long method here. It kind of builds your algebraic skills, and it also will verify you whether it's negative or positive, and you can verify here. Okay, so we'll go over one last one. You could try this one on your own to see if it makes sense to you, but I'll go ahead and do it. We want the equation to be in the form of mx plus b. All right, well, my y-intercept is, I'm just looking at the graph, it's negative 8, and you can see it right over here. We want to pick a point. I guess I'll just pick this point here, negative 1 comma negative 5. Okay, plug that in for x and then plug that in for y. And we're going to get negative 5 equals m times negative 1 minus 8. Negative 5 is equal to negative m minus 8. Okay? Well, I'll add the 8 first to both sides. 5, 6, 7, 8. So we get 3 is equal to negative m. This negative here is like a negative 1, so we'll just divide by negative 1. And we'll get m is equal to, well, negative divided by negative is a positive. 3 divided by negative 1 is just negative 3. Perfect. So my equation is y equals negative 3x minus 8. Absolutely perfect. Now you can see it over here. Absolutely perfect. 1, 2, 3, and then over 1. 1 over 3. You see it right there. It's perfect. Okay, you can verify it on the graph, right? Again, the long method guarantees you to give you the negative slope, but you should be able to recognize and observe that that is the case there. Thank you very much.